Hi and welcome to our channel IPM Leap. Today's math challenge is about decoding the sequences that you can see on your screen. And in each of these you have to find out the next two terms in line. These sequences are special because they don't fall into the category of an arithmetic progression or a geometric progression per se. And yet all three of them have the same pattern built into them, which makes them a delight to crack. In today's tutorial, we will also learn how to write the formula for a general term for these sequences, which can be very useful in a variety of questions asked in competitive exams. Let's begin. So as I said, the pattern followed by each of these has a commonality. The first step for us is to find out what is that. A very useful tip for decoding any sequence is to look at the differences. By the term differences, we mean the difference between any two consecutive terms of the given sequence. So let us focus on our first sequence. 2, 6, 12, 20, and we have to guess the next two terms, right? First, we look at the differences. 6 minus 2 is 4. 12 minus 6 is 6. 20 minus 12 is 8. 4, 6, 8. The pattern is clear. The next two numbers will be 10 and 12. For arriving at the next two terms of the given sequence, all we have to do is add the next difference, which is 10, to the last term of the sequence, which is 20. 20 plus 10 is 30. Similarly, because the next difference is 12, the next term of the sequence will be 30 plus 12, that is 42. These differences are in arithmetic progression because if you take the difference of these differences, that would be a constant. 6 minus 4 is 2 and so is 8 minus 6 is 2. So the pattern is loud and clear. The differences of differences is a constant for this series. Let's see if the same pattern holds true for the other two sequences as well. Our second sequence is 3, 15, 35, 63. We check the differences. 15 minus 3 is 12. 35 minus 15 is 20. 63 minus 35 is 28. Clearly, the differences of these differences is 8, which is a constant. We can extend this sequence of first differences. After 28, we will have 28 plus 8, that is 36. Therefore, next term will be 63 plus 36, which calculates to 99. And after 36, we will have 36 plus 8, that is 44. The next term after 99 will be 99 plus this difference, which is 44. And this will turn out to be equal to 143. Now we come to our third series, which is 5, 11, 19, 29 and so on. Same logic. We look at the differences first. 6, 8, 10. Obviously, next in line we will have the numbers 12 and 14. Therefore, the next two terms in line will be 29 plus 12, that is 41, and 41 plus 14, that is 55. And now comes a very important concept. In such sequences, sometimes they might ask for a particular term, say the 10th term, or they might even ask for the sum of first 10 or sum of first 15 terms, say. It helps if we are able to decode the general term for such sequences. And friends, since we noticed that the differences of differences is a constant in these sequences, always remember the general term, which can be denoted by TR, will be a quadratic in terms of R. TR can be assumed as AR square plus BR plus C, where A, B and C are constants whose value can be found out from the first few terms of the given sequence. Let me show you how. Let's take the first sequence as example. A general term of this sequence can be assumed as TR is equal to AR square plus BR plus C, Now remember, this equation of general term holds for every term. So the first few terms, say the first, second and third terms, can be used to find the values of our constants a, b and c. T1, our first term is given as 2. We put r is equal to 1 on both sides of this equation to get T1. We get T1 is equal to a into 1 plus b into 1 plus c is equal to 2. Similarly, we put r is equal to 2 on both sides. T2, our second term, will be equal to a into 2 square, which means a into 4 plus b into 2 plus c. And this is equal to the given value 6. And just one more equation required because we have three constants a, b and c to be evaluated. We put r is equal to 3 on both sides and get T3. A into 3 square, which means a into 9 plus b into 3 plus c, which is equal to 12. It's given. So trust me, this is a very simple set of equations to solve. All you have to do is first subtract equation 2 and equation 1. You will get 3a plus b is equal to 6 minus 2, which is equal to 4. Let's call it the fourth equation. And on subtracting equation 3 and equation 2, we get 5a plus b is equal to 12 minus 6 is equal to 6. Let's call it equation 5. Subtract equations 5 and 4 and straightforward you will get the value of a. 2a is equal to 2, so a is equal to 1. Put this value of a is equal to 1 in equation 4 and we will get the value of b. 3 into 1 plus b is equal to 4. So b is equal to 1. Put these values of a and b in equation 1 and we will get the value of c as well. C will come out to be 0. Once you have the values of the constants a, b and c, you have a well-defined formula for the general term. TR in this case is equal to r square plus r. Using this formula for the general term, we can find any term of the sequence. So for the 10th term, we put r is equal to 10 on both sides. T10 is equal to 10 square plus 10, which in turn is equal to 110. Now let me clarify here that some of my students are able to spot right at the beginning that 2 can be written as 1 into 2, 6 can be written as 2 into 3, 12 can be written as 3 into 4 and so on. In general, the rth term can be written as r into r plus 1. If you are able to do this right at the start, you have some significant effort and time saved for calculating the constants a, b and c. And that would be just excellent. However, I have given you a sure shot method which will work even if you didn't chance upon this shortcut. The method turns out to be extremely useful in such instances. Next, I am going to show you how to apply the same method to our next sequence 3, 15, 35, 63, ... The steps and even the equations are mostly same. So you may just pause the video and try out the calculations on your own. For me, using this method, my constants a, b and c turn out to be a is equal to 4, b is equal to 0 and c is equal to minus 1. The general term gets decoded as TR is equal to 4r square minus 1. So for the 10th term, all we have to do is put r is equal to 10 on both sides of this equation for the general term. T10 is equal to 4 into 10 square minus 1, which calculates to the value 399. Now, using the same algorithm of assuming the general term as TR is equal to AR square plus BR plus C, find the 10th term for the third sequence and post your answers in the comments box of the page below. The given sequence is 5, 11, 19, 29 and so on. That brings us to an end of this video lesson. If you enjoyed this math challenge and found it useful, don't forget to press the like button and also do subscribe our channel IPM Leap. Here is a glimpse of other popular maths videos on our channel. So keep watching and take care. Bye-bye.